There were a few main goals for the 30-metre EFASS hangar that we wanted to incorporate. I think for me personally, it was to capture everything that we've developed with all of the other hangars, everything that we've learned, and put it into one more up-to-date package that would be useful across the board.
The 30-metre was designed with UAVs in mind. So we had existing products that were really effective, well used for fixed wing aircraft and rotary wing aircraft, but we wanted a product that was tailored towards UAVs. So larger wingspans but low profile, and that's exactly what the 30-metre provides.
So there are a few differences between this 30-metre EFASS and the existing range of EFASS hangars. Apart from the obvious size difference, I think the complexity differed quite a bit, and it's a lot more complex because of the size of the door and the wind load it has to be able to take.
The original dated back to late 90s, early 2000s, so we've really used that technology and brought it forward to recent times. The product itself is still very deployable, but it's stronger. It's got more locations it can go to in the world. It's still very much a containerized, deployable hangar, but it's got more capabilities to go worldwide.
The heli door has a clear opening size of 30 metres wide by 6.8 metres high and an opening time of 2 minutes.
So this allows the RPAS to be taxied in through the rear, armed, and then taxied out the front. And that quick turnaround is essential for operational requirements.
These hangars will help support the very first global deployments of the RAF's Protector RG-1. So the contract came forward from NSPA NATO, but it was very much written with 31 Squadron and the RAF in mind. However, we've tailored this contract and delivered the contract on the NATO contracting scheme, which means that hopefully NATO nations are able to place orders with us more easily in the future.
We had a large amount of involvement from 5001 Squadron and 31 Squadron with regards to what they were looking for within the building itself. So the feedback from everyone on the project has massively shaped the final 30-metre developments. Just the information that we got from the squadron with regards to electrical supplies, how the drone will be kitted out within the building and what we had to look out for, along with 5001's input with the problems that they've experienced on the larger builds and how to overcome that with the different installation methods of PVC and some of the problems that they've come up against on site. To pull all of that together into one build has been a huge success for us.
So working with 5001 Squadron over years of having the RES product in deployment, we went through a lessons learned scheme, whereby we know what the regular components that may need additional maintenance were, and we try to design those components out. We've tried to tailor the product not just for the client but for 5001 Squadron and the build team that goes with that, so that it's easily maintained, everything's accessible, but very much follows the same line as the existing RES product.
So the benefit of doing the trial on site is iterations can be made really quickly. You can take drawings and ideas back to the engineers in the office, which is 5 minutes away, and get them implemented by the same day.
A lot of the research and development work was undertaken via prototype and via trial. Very beneficial, not just for demonstration purposes, but for Rubb to learn also. We got to see the beast itself, how it goes together, the speed at which it goes together, how different components work and react with each other. Lots of things can be determined on a drawing board and lots of things can be visualized. The most effective way of prototyping and research and development is to actually build a prototype. So we went through a lot of changes. I'm very proud of how the team came together. We had all sorts of departments involved with regards to the site installation team, the design team, the production team, and that tailored very much the product in which we have today.
So what I learned from some of the challenges of the R&D phase is sometimes the simplest answer is often the best. You can get caught up in overcomplicating things, which can drag on and cost a lot of money and time, and sometimes simplicity works just as well.
We tried to develop and build the structure in mind of where the building's going to be deployed to. So we know that a factory environment is not how this building's going to be built in the future. It's going to be on a flight line, it's going to be on an exposed area. So we tried to take that in mind. So not only did we develop the product itself, but the methodology in which you build the product was very well thought out. And what we have now is the biggest deployable structure that this company's ever developed.
So overall, I think the whole experience will help us in future projects, from what we've learned from the contractual side with NATO to having the confidence and experience in the R&D work that we've done, and the way that everybody's pulled together on this project as a company is just gave me a huge confidence boost that we can take on anything.